Business. Let me just make sure we're back in business. We are back in business. Thank goodness. Okay, so just to recap, we're looking at a boat that is in a stream or a river or something, and it's going downstream and upstream, and it goes 15 kilometers downstream in the same time it travels 9 kilometers upstream. Current is X kilometers per hour. So we have just analyzed this little chart before my smartboard decided to have a mind of its own. And we talked about how we came up with the column for speed, and we talked about how we came up with the column for distance. And then I was about to talk about this little guy that we reviewed yesterday, where we've got that rate is basically work divided by time, the amount of work that you do divided by the time that it takes you to do it. And for distance, speed, and time, right, that's just a variation on this little relationship where rate, in this case, is speed, and work is the amount of distance that you go, okay? So how does the time column, where does that come from? Well, in this little triangle, time is work divided by rate. So in that case, it's distance divided by speed. Okay, so that's where the 9 divided by 8 minus x comes from, or the 15 divided by 8 plus x comes from. Okay, all right, so that's the chart. Now, how can we get an equation to figure out the speed of the current? Well, we've got to look at the initial piece of information that we're given and figure out what have we not used yet in the chart. What piece of information has not yet been accounted for yet? Okay, so we've got to kind of read through it again. Sometimes this can be subtle. A boat travels an average of speed of 8 kilometers per hour in still water. Okay, we've accounted for that. The boat travels 15 kilometers downstream. We've got that. In the same time, it travels 9 kilometers upstream. The 9 kilometers we've got with a current of with a current x kilometers per hour, and we've accounted for the x kilometers per hour. What have we missed? There's a couple words there. Which words have I missed? Yeah. Same time. Yeah. Same time. The same time tells us that the two times are the same. Okay? The same time means that these are equal. Okay? And sometimes I like to do this as well, and for this example, this is pretty simple, so it might not be necessary, but I like to do kind of like a half English, half math equation, where I do something like this. The time upstream equals the time downstream. Okay, and if I look at the expression for the time upstream, the expression for the time upstream is 9 over 8 minus x, and the expression for the time downstream is 15 over 8 plus x. Okay, now we should kind of think a little bit about what would the non-permissibles be here? Or not the non-permissibles, but more what is the restrictions on x here? What could x be here that would make sense in this context? X is a speed. So what kind of values can we have for speed? It's not a velocity for those of you that are taking physics. It's a speed. Yeah. So it's got to be greater than 0. Yeah, it's got to be positive. Yeah, what else? Not greater than 8, less than 8, yes. Because if it's greater than 8, then it would actually go backwards when it's going upstream, right? Because the current speed would be faster than the speed of the boat. So also, we've got this restriction that x has to be between 0 and 8. Okay? All right, questions with that one? And that's all we have to do here. We don't actually have to solve this one. That's all we've been asked to do is to write an equation. Okay. Let's look at the next one. Anne cycles 6 kilometers to return a friend's bike. She then walks home. Her total time for the trip is 90 minutes. Anne bikes 4 times as fast as she walks. Okay. Write an equation that can be used to determine the speed that Anne bikes. So we want to know how fast does she bike. Okay, that's what we want to know, or we're not actually asked in this question to figure that out, but we're asked to write an equation that could be used to figure that out, right? So if we look at the chart, determine the speed that she bikes, and we look at the speed column, that's where the variable has been assigned. And in this case, it's actually been assigned to the walking speed. Walking has been given the variable x. Why does it make sense that biking is 4x? Yes.
4 times the speed she walks.
Yeah, because we're told that she bikes 4 times as fast as she walks. Okay, so this is 4x. Okay, the distances are both 6 kilometers. Why does that make sense? Yeah.
Because no matter if she walks or bikes, it's the same distance to her friend's house.
Exactly. She's going to her friend's house, which is 6 kilometers, and then she's going the same 6 kilometers back home. Okay, so they're both 6 kilometers. And then the time, well, we figured that out from the 2 columns that we filled out initially, and that's the same triangle that we did for the previous problem, right? It's distance over speed. Okay, so to get our equation, we have to use a piece of information that we haven't yet accounted for in the chart. What have we not yet accounted for in the chart? Yeah.
Is it the total time for the trip is 90 minutes?
Exactly. The total time for the trip is 90 minutes. So that's what we're going to use to build our equation. Okay? Total time for a trip. If we want to total up our time, what do we need to do to the 2 times? Add them. Yes. So here's our sort of half English, half math equation. The walk time plus the bike time equals 90 minutes. Okay, now we've got to be a bit careful here because we do know an expression for the walk time, that's 6 over x. And we know an expression for the bike time, that's 6 over 4x equals. Okay, now in our chart, what units are used for time? Hours, yes. So that means on the right-hand side, that 90 minutes also has to be in hours. Our units have to be consistent. Okay, how many hours is 90 minutes? Yes, 1.5 hours. Okay, there's our equation. What are the restrictions on x here? What makes sense in this context? X is a speed. What do you think? Yeah.
X must be greater than 0.
There you go. X has to be greater than 0. Okay. Next. All right. Two cyclists, Evan and Ina, are racing through the Rocky Mountains. Ina is twice as fast as Evan. The route they take is 100 kilometers long. Ina arrives at the finish line 2 hours earlier than Evan. Write an equation that can be used to determine Evan's speed. Okay, so again, if we look at this chart, we want to know Evan's speed, and if we look at where the variable has been assigned, it's in the speed column, which is what we the equation would be used to find the speed, okay? So Evan has been given the variable x. Ina is 2x because we're told she's twice as fast as Evan, okay? They're both doing the same 100-kilometer distance. That's why distance is 100 kilometers. And then time again is that same little triangle relationship. Speed equals distance over time, or time equals distance over speed. So that's the 100 over 2x and 100 over x. Good so far? I went through that quickly because we'd done it a couple times already. Yeah? Okay. So let's talk about the equation. What have we not considered yet in terms of information that we're given? What have we not used in the chart? Yes? Ina finishes 2 hours earlier than Evan. She finishes sooner than he does, okay? Now, this piece, right? She finishes sooner than he does. Now, when there is this difference in time, okay, there's a difference in their times, I really recommend that people do this, because when there's a difference, you're gonna like subtract times and you're gonna get 2. Does that make sense? Yeah? Because one is finishing 2 hours before the other. So if, like, let's say one of them's 8 hours and the other's 10 hours, the difference in the 2 times is 2 hours? Yeah? Yeah. Okay, when you subtract times, you get 2. So that's what we're gonna kind of use to build the equation. Yeah? That's kind of the big picture. People make a lot of mistakes with, do I take Ina's time and subtract Evan's time, or do I take Evan's time and subtract Ina's time? People often confuse the two. And we've already talked about the fact that with subtraction, order matters, right? If you take, if you switch around the order, you get a negative. So we don't want to do that. So what I really recommend that you do here is do this in the chart. Which of the two of these people is slower? Is Ina slower or is Evan slower? Evan's slower. He is slower. She is faster. Okay, so who's gonna have the longer time? Evan. If he has the longer time, he's gonna have the bigger time. We've gotta take the bigger time and subtract the smaller time to get 2. Does that make sense? Yeah. So to build our equation, basically the difference in their times is 2 hours. And it's got to be the slower time minus the faster time, right? Because if we took the faster time minus the slower time, we'd get -2. And you could certainly do that as long as you put -2 on the right side. That's totally a fine equation, just that most people don't put -2, they put 2. Okay, so we've got to take slower minus the faster equals 2. And the slower time is Evan. So that's 100 over x minus 100 over 2x equals 2. And that's your equation. Okay, so a lot of people with this difference in time, a lot of students will kind of work kind of quickly, and they will switch these two around. Okay, and then your equation actually won't model the situation. What is the restriction on x there? What does x have to be? X is a speed. If x is a speed, what makes sense for a speed? What kind of value could we have for a speed? Yeah? Greater than 0. Yep. Okay. Do you guys know what I mean, by the way, when I say it's a speed and not a velocity? Yeah? How many people don't know what I mean? Okay, so it's like a physics thing. Speed always is positive because it's just a speed. So when we're talking about like speeding on the street, it's just whatever speed your car is going. Velocity has direction. So velocity means, like, if you're going 50 kilometers to the right, that's positive 50. But if you're going 50 kilometers to the left, you're actually going negative 50. So here we're only talking about speed. We're not talking about velocity, okay? All right. So what I'd like you guys to do for the next, I don't know, let's say 10 minutes, is I want you to try practice questions 1, 2, 3, and 4, and 5 and 6, however many you get to, okay? So 1 to 6, I'm going to give you about 10 to 15 minutes.